Okay, so now we're going to be talking about fraction subtraction. So just like we did with addition, we're going to start out with like denominators. Then we'll move into fifth grade standards, which is uncommon denominators. Okay, so the very first example is 3/4 minus 1/4. They have the same denominator, so they are like denominators. And what we'll do, the denominator always will stay the same. So no matter what, your answer is going to be in fourths. 3 minus 1, we're just going to add or subtract, straight across. So 3 minus 1 is 2. You can simplify 2/4. For what we need to do, we don't need to, but I'll do it for you just in case you want to. So if you think of a picture, right, or an equivalent fraction, we know that 2 goes into 2, and so 2 is a factor of 2, and 2 is also a factor of 4. So when you reduce, you need to figure out what number goes into both the denominator and the numerator, okay? So because 2 is a factor of both, we can think, and we can go 2 divided by 2 and 4 divided by 2. Oops. Mess express. Okay, so 2 divided by 2 is 1, 4 divided by 2 is 2. So 2/4 is equivalent to 1/2. So those are equivalent fractions. Again, you don't need to reduce unless it specifically asks you to. However, I wanted to show you how to do it so that way you have that knowledge just in case. All right, example 2, we're going to do 3/4 minus 1/3. So just like with addition, when we have unlike denominators, we have to find a common denominator. And we're going to do that by listing the factors of both 3 and 4. So over here, we're going to list the factors of 3, and then we'll also list the factors of 4. So we're going to rote count by 3s. So we're going to start with 3, 6, 9, 12. We can go ahead and stop there, and then we'll do the 4s. So we're going to rote count by 4s. So 4, 8, 12, 16. As you can see, we do have a lowest common factor. So 12 is a factor of both 3 and 4. So that's what our common denominator is going to be. At the top, 3 times 4 is equal to 12. And for 4s, 4 times 3 is equal to 12. Okay? And then again, we're going to use those numbers, those factors, because that's what we're going to be multiplying these fractions by to figure out what our answer is with a common denominator of 12. Okay, so we're going to rewrite our equation, and this is where our parentheses practice comes in. So we're going to rewrite 3/4 minus 1/3, all inside parentheses. This is where we're going to go back to our factors and figure out what we're multiplying each number by. So 4 times 3 is equal to 12. Whatever you do to the denominator, you have to do to the numerator. Then over here, 3 times what is equal to 12? 3 times 4 is equal to 12. Whatever you do to the denominator, you have to do to the numerator as well. Now we will go through and just solve. Okay, so 3 times 3 is 9. 4 times 3 is 12. We are still subtracting. We don't want to change our operation in the middle of it. 1 times 4 is 4. 3 times 4 is 12. Now that we have a common denominator, we can go through and we can subtract. So 9 minus 4 is 5. 12 is your common denominator, so that can stay the same. So your answer is 5/12. If you're thinking maybe we can reduce it, is there any way that 5 goes into 12? Let's rote count by 5s. 5, 10, 15. Because 5 does not evenly go into the denominator of 12, you don't need to reduce that example. Okay, now over to our third example over here. We are going to be doing 1 5/8 minus 1 1/2. So with addition, what I suggested you guys do is bring your whole numbers over here and subtract them. However, the challenging part of that is if you're not quick on remembering what equivalent fractions are, if you do that, you might actually have to borrow. So it could make it a little trickier. So I'm just going to show you how to go through and solve it by making these mixed numbers improper fractions. We'll multiply to get a common denominator, and then we will simplify. Okay. So the very first thing we're going to do here is we have 1 5/8. So to turn our mixed number, into an improper fraction, what we need to do is your denominator is always going to stay the same. This is an 8, okay? 8 times 1 is 8, plus 5 is 13. So an equivalent improper fraction to 1 5/8 is 13/8. Now we're going to rewrite the subtraction operation, and we're going to turn 1 1/2 into an improper fraction as well. 2 times 1 is 2, plus 1 is 3, and we leave our denominator the same. You may recognize that 8 is a factor of 2 if you rote counted by 2s. 2, 4, 6, 8. Okay? How do we get there? 2 times what equals 8? So let's list out our factors. So we're rote counting 2, 4, 6, 8. There it is. So we'll notice that 2 times 4 is equal to 8. Now, you can do your factors of 8 just like we did on our addition side when we dealt with 8s. Now you can multiply 8. So there's our common. So it's 8 times 1 is equal to 8. You can multiply this by 1/1, or you can just leave it the same because you're not changing it when you multiply it by 1. So I'm just going to leave it for this example because I showed you how to multiply 1 by 1/1 in the addition. Okay? So we're going to do 13/8 minus, here comes our parentheses again because we're going to be doing some multiplication. So we need to remember 2 times what is equal to 8. Okay? 2 times 4. So 2 times 4 will equal 8 in the common denominator spot. And whatever you do to the denominator, you have to do to the numerator. So we'll go through and solve now. 13/8 minus 3 times 4 is 12. 2 times 4 is 8. So now we can go ahead and subtract because we have a common denominator of 8. We only change the numerator. So 13 minus 12 is 1, and our denominator remains the same as 8. So your answer for this is 1/8. Okay, now we're going to go to 3 minus 1 1/2. Okay, this is our last example for fraction subtraction. Just like we did in class, you can go through and solve these using models, and your notes have a lot of examples on how to use these, use the models to do subtraction. I'm just using the standard algorithm here to find a common denominator, but just know that you can also use the models. I would just reference your notes for that because you guys all have your notes at home, okay? So we have a whole number and we have a mixed number right here. So the very first thing that we need to do is we need to turn this whole number into a fraction so we can figure out what we're actually subtracting by, okay? So because we're talking about 2's in the denominator, okay, you guys might remember that when we have 2/2, that equals 1 whole. Then if we went on to challenge ourselves, 4/2 is equal to 2 wholes. Then we have 6/2, which is equal to 3 wholes. So we did do this in one of our math talks this year. So I just wanted to remind you of what we did. So that way when I write 3 as 6/2, you're not going to get confused. So 3, the whole number 3, could be considered a fraction as 6/2. And then we're going to subtract 1 1/2. We have common denominators. We have 2 as the denominator. So we don't need to change this, okay? So now what we're going to do, we have a improper fraction here, and we have a mixed number here. So let's turn this mixed number into an improper fraction so we can go through and solve, okay? So we're going to rewrite our equation. 6/2 minus 2 times 1 is 2, plus 1 is 3/2, because your denominator always stays the same. So 3/2, 3/2, is equal to 1 1/2. Let's go through and subtract across. So 6 minus 3 is 3. Because we have a common denominator of 2, your denominator is going to stay the same. 3/2. Now we can go back, since our numerator is bigger than our denominator, and we can turn this back into an a mixed number. And we should do that because we have mixed numbers in the equation and not improper fractions. If you had improper fractions in the equation, then you could just leave your answer as an improper fraction. Okay, 2 goes into 3 one time. You're going to subtract 3 minus 2 because 1 times 2 is 2. And your denominator stays the same. So your answer is 1 and 1/3.